Hey there, everyone. Let us discuss the next question. That is, what is the role of the properties of completeness and sufficiency in statistical inference, right? And with respect to that, we are given a particular, as you can see, that distribution, uniform distribution with zero theta. We have to find out the uniformly minimum variance unbiased estimator of theta. Okay. So here, first, let us write down the important. Properties of completeness and significance, which plays an important and very crucial role in construction of estimator and hypothesis testing. Okay, so first one is sufficiency. So what is sufficiency? Suppose we have a statistic x and we will say that it is a sufficient estimator of parameter theta if conditional distribution, if the conditional distribution of the sample given the statistic does not depend on theta. Okay, so what is mean that we have taken t as the statistic, okay, and the theta is the unknown parameter. Now from the sample we have to use the statistics to find out the unknown theta. Okay, now in simpler terms, let us say that tx contains all the information in the sample about theta. So this property helps in what? Reducing the dimensionality of the data while retaining all the relevant information about the parameter, because we know that parameter from a population is unknown here because population is too large and huge and it is difficult to estimate. So the sample that we are selecting from the population, which represent the population, hence the statistic calculated or estimated from the sample is such that it contains and retains the valid information required to estimate theta. It only helps in reducing the dimensionality of the data. Okay, so what is the significance then, if we want to understand in short? So the significance are, first one is data reduction. Okay, so that means we can summarize the data into a very smaller dimension without losing any information about the parameter of interest. And second one is efficient estimation. It means that sufficiency leads to more efficient estimation by providing a framework for constructing estimators that utilize only the relevant information in the data. So that's how we can get estimation which is efficient. Next, we have to discuss about completeness, right? Now, what is completeness? Let us define a probability distribution like this. P theta such that theta belongs to omega, right? So now this is let us say this is probability distribution. So it will be complete if for every measurable function g, let us say we have function g, there is one equation that needed to be satisfied. What? The equation E of theta function of t, which is the statistic, is equals to 0 for all theta. Am I clear? Now what it implies is that probability theta of the function g of t is equals to 0 is equals to 1. Now this is basically the definition of completeness. So what is the meaning? In simple terms, you can say here that the statistic t is complete if it captures all the information in the sample about any function of the parameter theta. Am I clear? Now, so in short, what can you say about the significance of this particular completeness as one of the important property of best estimator? Number one is existence of unbiased estimator. Completeness will be guaranteed only if the statistic in the question is unbiased. So first one is existence of unbiased estimator, then only we will go for completeness. And second one is optimality. So let's write down the first significance is existence of unbiased estimators, and second one is optimality. Now by optimality we mean what? Completeness along with sufficiency. So it helps in the construction of what? Uniformly minimum variance unbiased estimator, which is our UMVUE, right? Uniformly minimum variance, I will write it down here. That is UMVUE. which is uniformly minimum variance unbiased estimator. Okay, so which are what? Optimal. Okay, which are optimal, and thus from here we can get what? The uh, minimum variance among all the unbiased estimators is possible to calculate here. Okay, now let us find the uniformly minimum variance unbiased estimator of theta for a random variable x. Okay, so in the question what we have to find out? We have to find out this particular thing of theta for a random variable x. This follows what? A particular uniform distribution within the interval 0 and theta. So we have to find out the theta in this case, correct? Now, first of all, what is the expected value here? See, for the uniform distribution u0 theta, the sample maximum, okay, let us say the sample maximum, which is xn, is a sufficient statistic for theta. Now, to show this, we have to use what? Factorization theorem. Now, expected value of xn is equals to n by n plus 1 theta, okay? And this is definitely, as you can see, is biased, because we know in order for unbiasedness, we only need theta on the right side, right? So, however, if we take statistics tx, which is n plus 1 by n xn, then tx is unbiased estimator for theta, okay? And variance of this particular is theta squared by n of n plus 2. So thus we can say that the uniform minimum variance unbiased estimate of theta for the uniform distribution is this, that is n plus 1 by n xn.